Okay. It is over now. First class attendance, I think it's over. Whoever was rushing there, you can roll number. This is 120. Any more left than you can say? Then we'll start with the next class. Okay. Uh, yeah, one more thing. Until then, you see, the analysis one I was telling you about the analysis of structure. I'll be taking your section A, this one, Thursday. Now. See, correct your in your timetable. Okay, correct your timetable means in Thursday you are having BCE 701. That means analysis on the first period. But I have class on I think in section B that day. So third class Thursday, third class 11:15 to 12:15. I'll take your AOS analysis of structure. Okay, and this one. Third class BCE 705 you had BCE 705. This will be taken in the first class Thursday 9:15 to 10:15. I think yeah, Bishwadeep sir will take your class 705 BCE 705 Thursday first class, and Thursday third class analysis 11:15 to 12:15. Okay, understood? Am I audible? Hello. Okay. So analysis I'll be taking on the Thursday, third class. Vishwadeep sir will be taking on the his first class. He will be taking. Oh, sorry, his third class he will be taking in the first class. Okay. Analysis. The first, the three classes were there in your section. That one class I'll be taking, two class your Wednesday. Rituraj sir will be taking first and second class. Have you has Rituraj sir taken any class on analysis of structure till now? No, 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 no. No. Okay. So I think tomorrow he'll take your class. First and second class. He'll take your class. I'll take on Thursday, third class. I'll take the plastic analysis chapter and the other one he'll take. Okay, so now let's come back to DOS. Now we'll be doing a problem on circular tanks. Okay, 7 minutes. Okay. Okay. Wait. DOS 6M 6M. So now we are going to, what we are going to do, we are going to design a circular water tank here. So what does the question says us? Okay. We have, this is your question, circular water tank resting on ground. We have what? Design a circular water tank for the following data. The diameter of the tank is given to be 6 meter. The depth of the water is given to be how much? 3.75 meter. Tank rests on the ground. Use M30 grade of concrete, Fe415 grade of steel. Okay, so this is design a circular water tank for the following order. This is your question, and we have to design a circular water tank here. Okay, so now let us go and do the solution, start the solution. Here you will see the depth is given, the things are given what? 1 minute. Huh? Yeah. So depth of the water is given to us. Depth of the water is given to us 3.75 meter. Then we have the diameter is given to us to be, wait, this is your diameter is given to you of the tank. Depth of the water tank is given to us 3.75. We have the diameter 6 meter. Let us assume the freeboard to be 250 mm. Earlier also we had taken, tanks always we have to take a freeboard, we know that. So we are assuming here it to be 250 mm. Height of the tank we have assumed it to be 3.75 plus our freeboard, which is 250 mm, 0.25 meter. So we have our height, total height of the tank to be 4 meter. Now there will be obviously hook tension. This is tension, okay. TENTIO. Hook tension, TEN. Maximum hook tension at the base is how much? Gamma W into H into capital D by 2. Capital D is, we have the diameter of the tank here. Okay. So the maximum hook tension which is occurring here due to this water pressure is gamma W into H into D by 2. So gamma W we know 9.81, and height we have 4 meter. This one height 4 meter, at a depth how much? D by 2. Oh, sorry, this one D by 2, the diameter divided by 2. So we have got our maximum hook tension to be 117.6 kilonewton meter. Height. Now the area of steel required will be how much? This is tension, hook tension. So this was actually T, hook tension T. So T by sigma ST is equal to, T is this divided by our sigma ST. Sigma ST again like the same, like in the rectangular tank we had checked in the IS code table 2 and 3. So from there we'll get again sigma ST for M30 grade of concrete. Okay, we got how much? Sigma ST is 130. So now we have area of steel required is 905 mm square. Okay, 1 second, huh? Hello? Bye. Okay, very best. Yeah. So area of steel required is how much? T by sigma ST. So we got our T is this much, the hook tension, and we have how much? The sigma ST we got from table 2 and 3. Right. So now we can provide this thing. We can provide 12 mm or 10 bars, whatever you want. So if you when you're designing, so we are providing here 12 5 bars at 200. Sorry, at 120 center to center spacing. So the area of steel provided will be how much? The area of the bar divided by the spacing. We got our area AST provided how much? 942 mm square, but we had the requirement was how much? 905 mm square. this much area of steel required was 905, but the provided, how much we have provided? We have provided 942 mm square, which is greater than the required one and is satisfying the condition, so it is okay for us. Okay, so the design is okay. We can provide this much dia bars at this much of spacing. Okay, now at the top 2 meter, at top 2 meter from top, how much we have? T is how much? The total hook tension will be gamma W, gamma W H into D by 2. So 9.81 at the height 2 meter from top. Here we did what? 4 meter for the total height. We have taken out the main reinforcements this much. Okay. So at the 2 meter from top, how much we have? This much tension, 58.86 kilonewton. Wait. So we are having now how much? 58.86 kilonewton. Now for this 2 meter from the top, we have how much? The required area of steel. The required area of steel is how much? T by sigma st. So T is how much? Our 58.86, and sigma st we know. So that is 452 mm square. Area of steel required is this much for this 2 meter from top. So when we provide this much of bars, 12 mm at the rate 250, center to center, area of steel provided is how much? Pi d square by 4 spacing. So we got our area of steel provided is 452 mm square. The same, which is equal to the required one. So it's okay. If it should be equal, this much is required, and we have provided this much, so it is okay. It is equal. Now we can go for the thickness of the wall according to IS 456, where we have sigma st is equal to sigma st is equal to T by Ag plus m minus 1 ast. Okay, so sigma st we know it is 1.5. T we have calculated already, 117.6. This one, the total height h, we have 117.6. The hook tension, so that is this much. Now we are having Ag, the gross area, we have taken it to be 1 meter, 1000, that's why m minus 1. M we have to calculate the modular ratio. Modular ratio is how much? Okay, they have not done, so I'll show you here. So T we know, area we know, M minus 1, M we don't know, area of steel is how much? 1 second. This one. For the total, this hook tension for the total 4 meter height of the tank, we have how much? The area of steel provided is 942. So here We have the thickness, or to check the thickness of the wall, we have how much? T is this much, area is 1000. We have then we have how much? Gross area is 1000 into T, that is B into T, the per meter width. So we have B into T, thickness will be like this. Then we have area of steel, we know for 4 meter, the total height of the tank, we have 942. Then we have M minus 1. M minus 1. M is what? Your M is modular ratio. So, your M was how much? Your M was 280 by 3 sigma CBC. 280 by hmm, 280 by 3 sigma CBC. So that we can find out 280 minus 3 sigma CBC. Sigma CBC is 10 from table this one, from page 4, IS code 4, IS 456 page 81 we will get this. So we will have how much? We will have 280 by 280 by 3. You will have 3, and sigma CBC is how much? Sigma CBC from table, it is 10. Okay. Sigma CBC is 10. So we got how much? This value you will get it to be 9.33. 9.33. 9.33, so 9.33 m minus 1, this much. So we will get our T. We can easily now find out calculate our C value from here. So sorry, T value. So the thickness we have got it to be how much? The thickness we have got it to be 70.55 mm square. Okay. So we can provide the thickness to be 100 mm. So we will provide the thickness, therefore the thickness we will provide it to be 70.5 mm na, so we can take it to be 100 mm. थोड़ा सा ज़्यादा we'll take somewhat more, so 100 mm. Okay. Now if we see, now after knowing the thickness, we can do the what? Distribution steel reinforcement we can provide. Distribution reinforcement or the steel. So for that, distribution steel, area of steel, minimum area of steel is we know already 0.24% of the area. So 0.24% of the B into D, and our D, the thickness is how much? 100 mm. So the minimum area of steel is how much? 240 mm square. Now we can provide 10 mm. We can provide distribution, since it is distribution, we can provide 10 mm, 8 mm, whatever we want. So, okay, 10 mm. Now for here we are providing 10 mm 5 bars, 10 mm 5 bars at 220 mm center to center, or 200 also you can. It is up to you how you are designing, how much this diameter of bars you are taking, how much spacing you are giving for distribution. But you know that it should be a smaller diameter, 8, 10, like that, 8, 10, 12. So provide here we are providing 10 mm bar dia bars at 220 mm center to center. So the area of steel required here is how much? 3 56 or 86, 356 or 86, something like that. So that is greater. So this is greater than the minimum area of steel required is how much? 240. But we have got how much? After providing this much 10 mm, this is the provided one. provided how much we have got. This was the minimum area of steel required is this much, but we have provided this much, 356. So obviously this is okay for us, the design is okay for us, we can draw this. Then we can now, since we know for a circular pen it is easy and simple, now we can do the base slab design. We have provided the distribution steels and the main steels, now we can do go for the design of the base slab. So base slab, we will find out what, consider the thickness of the base slab to be 150 mm. If we consider the this base slab, okay, done. So base slab, if we consider the thickness of the base slab, 150 mm, okay. If we provide the thickness of the base slab is 150 mm, then we have what? The area, minimum area of steel will be how much? 0.24% we know. So it is 0.24% of the, this one, the area. So that is equal to B into D. So D we know it is 100 here. So area of the minimum area of steel is 240 mm. So we can provide the 10 mm fire diameter bars. We can provide 10 mm dia bars at 220 center to center. So the area of steel provided is how much now? The 357 mm square. Okay. So we'll have how much? AST provided is 357 mm square. So which is obviously greater than the this one minimum requirement. Okay, so it is okay for us. So therefore, our design is okay. The base slab we have done. The minimum area of steel required is this much, but this much. But we have provided 10 mm. Now you can provide 8 mm also as you wish. But for this question, we are providing 8 10 mm, and also we have got greater than the required one. So it is okay. Our design is okay here. Now, if I show you the photo here, I don't have it now, but I can show you. Wait, I'll take time. Okay. I'll show you the figure here. The figure, that means the reinforcements which we have done, the base slab design, then we have put on the reinforcements. So I can show you here. It is taking time to receive the image. Till then I'll take your attendance for this class. And the image is receiving, okay. So it is taking time to receive the image. I'll show you. as soon as it's downloaded. Okay, roll number 1, absent. 2, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 10, roll number 10, 11, 12,
Present ma'am. 10%, ma'am.
12,
012 present ma'am.
14,
11 present, ma'am.
Roll number present, ma'am.
13, 14,
Present, ma'am.
15, 17,
17 present, ma'am.
18, 19, 20, 21, 23, 24, 25, 26, 27, 30, 31, 32, 34, 36, 37, 38, 37. Hmm?
Present, ma'am. 36.
37, 38, 39, 40,
Yes, ma'am. 39.
40, 42, 43, 45,
48
48,
present ma'am.
48 present, ma'am. 48.
49,
49 present, ma'am. 49.
50, 51, 52, 54,
Yes
57,
ma'am.
57, 58, 60,
60 present, ma'am. 60.
61, 61, 63, 99,
Yes, ma'am. 99.
101,
Ma'am.
104,
Present, ma'am.
106, 108,
108 present ma'am.
108, 100,
Present, ma'am.
109,
109 present, ma'am.
triple one,
Present, ma'am.
113,
Present, ma'am.
114,
Present, ma'am. 114.
118, 120, 124,
124. Yes, ma'am. 124.
133,
Yes, ma'am. 133.
134,
Ma'am 134.
136,
136 present, ma'am.
143, 144, 145,
145.
149, 149, 151,
49 present, ma'am.
151, 151, Okay, I have got this. The image I have received now. Let me show you. Hmm.
0.05%, ma'am.
Huh?
0.05.
How much?
0.5.
0.5. 1 second.
Yes, ma'am.
The roll number. Roll number 10.
Okay.
Thank you, ma'am.
Where is okay, where it went? This PC users image. Okay. See here, this one is whatever you have designed in the circular tank. These is all about those what we had done. We had done the base was 150. We have taken the thickness 150. The depth, the total height of the tank was how much? This one, 4 meter from here to here, 2 here to here, 2 meter, 2 meter, 4 meters. We had provided area of steel here at 4. The mean bars were how much? 12 mm. This one at 120 mm center to center. This one's the main bars. Okay, so we had this 12 mm at the 120 mm center to center. Then we had at sorry at 2 meter top we had how much? 12 mm dia bars at 250 mm center to center. We had calculated. If I show you this one, you see this one. So here you see what we have provided. We had provided 12 mm 5 bars at 120 mm center to center. For the bottom 2 meter, this is for top, that this was for all entire one. So that was how much? This one. For the bottom we had 12 mm 120 center to center spacing. This spacing was more at the top. 12 mm same tire but 250 mm we had kept. So it is that. Then we had what? This is 4 meter. Okay. Then we have the distribution bar. No? The distribution bar we had given the vertical distribution. How much we have given? We have given it to be 8 mm at the 270 center to center. 8 mm you can give, 10 mm you can give. Okay, but in our question I think the student has done 10 mm one, 10 mm distribution he has taken. This one, where it is, sorry, this one distribution he has taken 10 mm. So but this diagram is for 8 mm. So you can, since this question we have done is 10 mm, so you can write it this to be the vertical reinforcements is how much? 10 mm center to center. Okay. Hmm. So it is how much? 8 mm center to center, spacing at 270. Sorry, 8 mm diameters at 270 center to center. This was vertical. Okay, now for the base layer, what we had done for the base layer. If we coming to the base layer, also you see here the thickness of this wall is how much? 100 mm. We had taken this one thickness. We had taken it to be 100 mm. 100 mm. this one. But for the base slab, we had taken it to be how much? Base slab, we have assumed it to be 150. See here, 150 mm, and this one, base slab 150 mm. Then we have provided the bars to be how much? At the bottom base slab 8 mm at the rate 270. But what he has taken here, base slab also he has taken it to be 10 mm, 220 center to center. But in the another question which we were doing, so there we had taken the base slab reinforcement to be how much? 8 mm at the rate 270 center to center on top piece. Okay, on this top piece here. Okay, so this was the figure. Okay, for the circular section which we have done this now. This is 2 meter, 2 meter, everything is done. Yeah, 4 meter. Joint ceiling compound is here. 120 mm center to center. Okay, so once you do this, you can understand you can draw easily this thing. If anybody is left out, please give your attendance. If I have missed your attendance, otherwise I can you. I'm telling you, those who are marked absent. Okay. One more time. Okay, some of them have written on chat also. 36. 36 to present only. 36, 39, present. We have 39, 49, then 149 is there. 134 is there. Absentees, I'm writing your, here itself I'm writing, okay. Absent. I'm just calling out the name. Okay, those whose names are marked absent for this class, I'm calling out your names. If you're present, you inform. 1 is absent, 2 absent, 4 absent, 6 absent, 7 absent, 8, 9, 10 absent, 15 absent,
10 present, ma'am.
15 present,
Roll number 10.
10.
Yes, ma'am.
18 absent, 19, 20,
Roll
20.
number 8.
Huh?
Ma'am, number 8.
Huh?
Number 8.
Huh? 18.
Present.
Jamil. Please write in the chat box.
Yes, ma'am. Yes, ma'am.
Huh? Write in the chat box 18 or 19. I don't know. I'm not hearing you. Please write in the chat box. 20. Okay, 18. Jamil. 19 absent, 20 absent, 21, 23, 24, 25, 26 absent, 30 absent, 30 absent, 31, 32, 34 absent. Then we have 37, 38 absent, 42, 43, 45 absent.
Ma'am, 45 present.
Okay, 45 present. Then we have 50 absent, 51, 52, 57, 58 absent, 61 absent, 63 absent, 106 absent, 118 absent, 120 absent, 143, 144 absent, 151 absent, 133. Bimol wrongly present though. Okay, then it's done. Nobody extra is there now. Okay, thank you.
Thank you, ma'am.
Thank you.